How to find the readings on the Vernier caliper? The instructions are already here. Allow me to make mention the following. Like I said, the Vernier caliper has internal jaws. These jaws are used for measuring the inside diameter of a hollow object. The outside jaws are used to measure just the outside diameter. Whether an object is hollow or is just a solid object, the external jaws are pretty good for that. Then we have the Vernier scale, like I indicated in the previous presentation, that this has the units in millimeters. Then the main scale is in centimeters. So we need to make sure that this millimeter is converted to centimeter, and then we find the value. There are two important conversions that must be done, but allow me to skip those two conversions and just go direct to the easiest way. How do you do it? How do you measure either the diameter, the internal diameter, or the external diameter? Allow me to use my explanation on this diagram that we have here. So first of all, for you to use this instrument, you must take some precautions. Some of the precautions that we have is that you make sure that these jaws are cleaned before the object is placed in between. Because in a moment where these jaws have got a little bit of some dirt stuck on them, and then you place an object, meaning the thickness of this object will not be the actual one that will be recorded. That's number one. Number two, you have to make sure that this instrument is zeroed to avoid zero positive error as well as zero negative error. All that will be discussed very soon. How do you take the measurements? I'll be reading point by point with few explanations. Put an object, after doing all those precautions, put the object to be measured in between the jaws. So whether it's an internal jaw or an external jaw, you have to make sure that this object is positioned between the jaws. But in reality, these jaws are able to slide to and fro. Now, how do you make sure that this object is firmly held without the sliding back of the jaws? This Vernier caliper has got a knob, more or less like a car wheel, that you have to tighten. When you tighten it, meaning these jaws will not be able to slide back. So you untighten it so that these jaws are able to slide back towards able to slide towards the object. When the object is firmly held, you tighten it so that even if this object is removed, these jaws will not be disturbed. So the object here is positioned as per instruction number 1. Secondly, you will find that, so they are saying that the information you will get from this point here has been zoomed in, and this is what they are showing. So we have this as our main scale. We also have this part as, now just this part here, this is our Vernier scale. Our Vernier scale. This is our main scale. So measurements you start getting from the main scale. You start from the main scale. Which one do you get? A lot of numbers here. We have to get the reading from the main scale that appears before the 0 mark of the Vernier scale. So our Vernier scale, this is our 0. Very important. Get the reading from the main scale that appears before the 0 mark. So if this is the 0 mark of our Vernier scale, therefore the reading that we're going to pick is this one. Get the reading on the main scale that appears before the 0 mark on the Vernier scale. We have identified the mark that we're going to itemize. That has been itemized, that we're going to get the reading from. But what is the reading on this mark here? If this is 1 centimeter, this is 2 centimeter, and these in between are 10. Therefore, 1 mark represents a 0.1 of a scale. So if this is 1, then this would be 1.1, 1.2, 1.3, 1.4, 1.5 halfway. The 0.5 is always longer. 1.6, 1.7, 1.8, 1.9, 1.10. So meaning we change to another unit, which is a 2. So meaning this unit that we are interested in here, this mark is a 1.2. This is in centimeters. From the main scale, we have nothing to do. We'll just get it the way it is. Allow me not to follow what is here. Allow me not to follow what is here. I'm going to show you. I said the easiest way. So allow me to use things my way. That is from the main scale we are settled. What about the Vernier scale? Which one are we getting? We are saying when you look so closely, among the lines, the marks that are on the Vernier scale and the ones that are on the main scale, there are some that are coinciding. Kalaini kachoka pamwamba kabwela kapitilila kufika na ku Vernier scale. That is a line that we are supposed to get. So let's check around. Allow me to remove all the writings that has been done here. Let's check around. Let's check around. We're now interested from the Vernier scale. The Vernier scale, we're having a 0 here and we only have a 5 up to here. So among the lines that we have here, there's one just coinciding with another mark from the main scale. So look at the 0. This 0, there's nothing on top here. This 1, there's not. Now here they are 5. So meaning each line represents a mark, or each mark represents a unit. So if this is 0, 1, 2, 3, 4, 5. So let's check. Our 1, there's nothing on top here. Our 2, there's nothing on top here. Our 3, there's nothing on top here. Our 4, there's nothing. But our 5th one, this is the one which provides a consignment. Therefore, from the Vernier scale, this is the line that I'm going to get. What number is that? 5. So now I'm going to get that 5, which is in millimeter. I said there are 2 more conversions that must be done, but just allow me to show you the direct way. Whatever you get from the Vernier scale, multiply by 0.1. And the answer there will be 0.05. So always, and now this 0.5 is already converted to millimeters. So the 0.01 weight is coming from, it's coming from the mark that you get from the Vernier scale must be divided by 10, so that it's converted to centimeter. So this gives us 0.1. The accuracy of the Vernier caliper is 0.1. So again, this multiplied by 0.1, that's what is giving us 0.01. So to avoid the multiple conversion, whatever you just get from the Vernier scale, multiply by 0.01. And that answer you'll get, be rest assured that it's already in centimeter. So once you have the units from the readings from the main scale here, we also have the one from the Vernier scale. So these now can be added. And this is 0.05 centimeters. So this can be written as 0.2, as 1.20. So that 0.5 will give us a 5, 2.0 will give us a 2. We add a point here, 1.0 gives us a 1, and this is already in centimeters, which is the same as the one they wrote here. But my method is different from the counting they did, because I just wanted you to show or to know the direct method that is used. But if you wanted me to show you the conversion and all that, pretty good, I can still show. Have you seen the question, my dear?
Yes. Sir,
Yes.
what if like there 5 where I said the line bypassed there.
Mm-hmm.
What if there are two numbers like that? You
Mm-hmm.
you just add or
There can never be two lines. It's just one. Always just one.
it's always there.
Always, it's always there, and it's just one line.
Mm.
Let me show you another question. Now, this question, remember what I said, that these questions do come a lot in past papers. So allow me to show you an extract from a past paper, 2017 GCE. So blah, 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 blah. Let me show you science, paper 1, 2017 GCE, so that I show you that these things are very, very important that we are from discussing. And because the micrometer screw gauge is easier, they like bringing the vernier caliper. So this is a micrometer screw gauge, but let's go to a vernier caliper, which we have discussed now. So just hold on a little bit until we get to a vernier caliper, then you'll understand that these things are very, very, very easy and much. This is the vernier caliper I'm talking about. So this is coming from 20, let me just itemize the year. So this is coming from, let me even increase the font. This is coming from, the science we learn is 5124. I'm sure it's yet to change. 5124 science paper 1, which is physics. The year is 2017, 2017, and it is GCE. And the question number is B, which is standing for section B, question 1. So let's look at the question that we have. Question says, allow me to even take it a little bit up here. Better. It says, have you seen that? This is where that question came from, where given the velocity, the units, and blah, 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 blah. This is where I extracted it from. But except that by then, we had not yet looked at the vernier caliper. So we say that they have already indicated that this is the main scale. But we must be rest assured that this is in centimeters. And then the vernier caliper is in millimeters. Therefore, what is the reading of the vernier caliper? 2 marks. Now, in science, do not write anywhere. The space that is left for you to solve is this space. So, how do we do it? First of all, we are going to get, remember the instructions we said we get the reading from the main scale that appears before the 0 mark. So this is our 0 mark on the vernier scale. Therefore, the mark that appears before that we must get is this one. This is what appears before the 0 mark on the vernier scale. But that mark is before 8. So it's very important that you understand the numbers that you are dealing with. This is 8.0. This is 9.0. So 8.1, 0.2, 0.3, 0.4. Like I said, 0.5 is always longer. 0.6, 0.7, 0.8, 0.9, 8.0, 9.0. Meaning this line which is here, it must be 7.9 because it is a mark before the 8.0. And this must be in centimeters. So from the main scale, just allow me to type so that I don't maybe waste time. From the main scale, what we have here is 7.9 centimeters. Maybe this is too big. Let me see if I can reduce it a little bit. Okay, so from the main scale, this is what we have. What about the Vernier scale? We said from the Vernier scale, we get the mark that does the consignment, that coincides with the mark from the main scale. Like you had asked the question, it is always 1, and that line is always there. Which one is it? This is our 0. Now this one goes up to 10. So meaning this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But which one are we going to use? The one that coincides with the one on the Vernier scale, on the main scale. So which one is that? This is the one that we're looking for. Maybe let me show the arrow from down. So this is what we are looking for. So because this is what we are looking for, therefore, let's find it. Which number is this? This is a 5, because this is a 0, this is 1, this is 2, this is 3, this is 4, and this is 5. So this is 5. And this 5 is in millimeters. Is in millimeters. And therefore, we are going to get this. We multiply by the 0.01. This will give us 0.05, and this is already in centimeters. So meaning now we are going to get this and add it here. So we are saying that the Vernier scale, the readings that we have here are, the readings that we have on the Vernier scale are 0.05, and these are in centimeters. Then we're going to add them. How do we add them? So here you can also indicate a 0, so that 0 plus 5 will give us a 5, and these are already in centimeters. 9 plus 0 will give us 9. We put a point here. 7 plus 0 will give us 7. So this was the reading on the Vernier scale. As simple as that. As simple as that. Are we okay?
Yes.
As simple as that. That is how you get the reading on the Vernier scale. What about the micrometer screw gauge? Micrometer screw gauge is a little bit different from the Vernier caliper. I don't know if I can even find another one here. I'm not too sure if I can find one. Okay, I'm not too sure if I can find one. No, here. So we can even try looking at which of the following instruments would be used to the answer, the word here is accurately measure the inside, and I said that the only instrument that has the internal jaws is a Vernier caliper and the engineering caliper. But between the two, which one is accurate? It's this one, which has the numbers on its own. This one depends on a meter rule. Therefore, it's not accurate. So let's see if we can find another one before we switch to micrometer screw gauge. Let us see if we can find another one, kinematics. Let me see if we can find another one. Oh, I think there isn't. We can just go to a micrometer screw gauge. So micrometer screw gauge pendulum. The micrometer screw gauge is not very far, not very much different from the vernier caliper. There are only just few things that makes it different. So this is what we have as our micrometer screw gauge. So like I earlier indicated, that this micrometer screw gauge only has the external jaws. And these external jaws are pinned inside with what is called the anvil, pinned inside with what is called the spindle. So this anvil here is stationary. What moves to and fro is this spindle. How does it move to and fro? Do you have to pull it? Do you have to push it? The answer is no. You rotate the ratchet. So when you rotate the ratchet in a clockwise, it means you are closing, you are pushing this spindle towards the inside. And when you rotate it in an anti-clockwise like that, means you are unscrewing, you are opening, you are causing this spindle to go an outward way, thereby giving space to this object. Then we have these sleeves. These sleeves here, that is where we have the main scale. The whole lot of it is a main scale. And then here on the radius, on the sometimes called radius from something secular, this radial or secular scale is contained on the thimble. So the thimble, that is where this ratchet is inserted. Now, what do you have to know more about this? Number one, because this can measure something which is as small as 0.01 millimeter. Can you think of a millimeter being divided into 100 species? That's quite small. So meaning even dust being around here can cause a havoc to the measurements. So one of the precautions that you must do is that this anvil as well as the spindle must be cleaned before an object is introduced between the jaws. The anvil and the spindle must be cleaned thoroughly as a first precaution. Secondly, what we are saying is that this instrument should be zeroed. When I come with the actual instrument, that's when I'll show you how the zeroing is done. But I've given you two precautions: clean the anvil and the spindle, zero the instrument. But how do you take the measurements? Let's see how far this is different from the vernier caliper. First of all, we can even see that what we had on the vernier caliper, the vernier scale only had numbers on the top. With a 5 here, a 0, and the bigger number here in centimeters. But this one, on the sleeves, the main scale is good numbers. One on top, the other one down, which is different from the vernier caliper. The numbers that were down here, they are the ones from the vernier caliper. But here, these numbers up and down, they are both meant for the main scale. What are they used for? The number which is on top is a whole number. The number which is below it is 0.0. It's half. So like we have here, this is 3, this is 3.5, this is 4, and this is 4.5. That's why this was written as 4.5. That's how a little bit is different from the vernier caliper. What else is different? Look at the radius scale. From there we had the vernier scale. Here we have the radius scale. How is it different from what we have there? It's different in this way. Secondly, the main scale from the vernier caliper was in centimeters, the vernier scale in millimeters. But here, the main scale is in millimeters. The radio scale is also in millimeters, or the circular scale. However, the circular scale here, we also do the consignment. Like the way we did the Vernier scale consigning with a mark from the main scale, here our consignment is always this line which is drawn here. This gives us the reading from the circular scale that we must interested in, like the way they indicated here. Now, how would you know that line? You will be guided by the graduation which is done. So if this is 10, this is 11, this is 12, and this 12 is in millimeters. Then I'll also show you the number that you must multiply with. That's what we are doing. So you pay attention to the mark that is close here. You also pay attention to the consignment that you're going to have right over here. So, how do we do it? Let's look at this example that we already have here. How can we take the measurements? How can we take the measurements? So the measurements can be taken by, first of all, considering the last mark that, so meaning, if what we had here, let me now try to change some scenario. If what we had here was if this is what we had, then we could have said that the mark that we are going to get here will be this. This is what we could have obtained, because that's the only mark that is very close to this point. But that is not the case. This is not the case. What is the case? The case is this. The case is the line that we are interested in is this one, because this is the one which is very close to the radio scale. Now, which number are we going to get? So if this is 4.0, then this will be 4.5. So from the main scale, what we have here is 4.5 millimeter. It's 4.5 millimeters. What about radio scale, which is also called the circular scale? What do we have here? What we have is this line here. And if this is 10, we are saying we are picking this one here. If this is 10, 11, 12, 13, 14, 15. So therefore this will be 12. Now this 12 we are also multiplying by 0.01. Why it also be 0.01? Because this is the accuracy. For the other one, the accuracy is 0.1, which we're supposed to multiply with 0.1. Then the answer you divide by 10. That's how it was giving us 0.01. But this one, this is the accuracy, and this is what you multiply with. And when you do that, it gives you 0.12. And this is also in millimeters. So because both from the radio scale and the main scale are in millimeters, therefore we're just going to add them. So what do you have here? 0.12 millimeters. And when we do the addition here, of course, the units are millimeters. So we can put a 0 here, so that we say 0 plus 2 will give us a 2. 5 plus 1 will give us a 6. We'll put a point here. 4 plus 0 gives us a 4. So meaning the external jaws of this object that we were measuring was of length 4.62 millimeters. And that's how this answer was about. Are we okay?
Yes. Sir,
Yes.
on the main scale,
Mhm.
they're saying that the last
The last
the last
mark, yes.
the last digit
Mhm.
is the one that we use. Yeah?
Yes, that's the one we get. So let's say here, our last mark, because there's nothing down here, there's nothing there. So we'll pick 5.0. Here, we'll pick 13.0. Here, we'll pick 11.5, which is here. Are we okay?
Yes.
So this is the work that I'm going to send to you right now. Thank you so much for your time. Today, I think we have a bit of a productive day. So
Okay.
I am sending this week right now, and as well as the recording will be uploaded on YouTube, then I'll send it to you.